We're going to explain Modbus RTU over TCP in Python. Modbus is a widely used communication protocol for industrial devices. RTU stands for Remote Terminal Unit, representing the serial communication method. However, Modbus RTU over TCP IP adapts this serial protocol to use the TCP IP network protocol, enabling communication over Ethernet. This is handy because Ethernet is much more common in modern industrial settings than serial connections. Setting up the environment. First, you need Python installed on your system along with the PyModbus library. You can install it using pip install PyModbus. This library provides the necessary functions to interact with Modbus devices. 2. Establishing a connection. To connect to a Modbus TCP device, you'll need its IP address and port, usually 502. The PyModbus library offers the Modbus TCP client class for this purpose. You create a client object by specifying the IP address. Client equals Modbus TCP client 192.168.1.10. Then connect using client.connect. Remember to replace 192.168.1.10 with your device's actual IP address. 3. Reading data, holding registers. Modbus devices often store data in registers. To read data from holding registers, addresses 0 to 65535, use the read holding registers function. This function takes two arguments, the starting address of the register and the number of registers to read. For example, result L client read holding registers 1-2 reads two registers starting from address 1. The result will contain the values from those registers. You'll need to check the result registers attribute for the read values and handle potential exceptions, like connection errors. 4. Writing data, holding registers. Writing data is similarly straightforward. The write register function allows you to write a single value to a specified register. For example, client write register 10-123 writes the value 123 to register 10. Write registers allows you to write multiple values at once. 5. Closing the connection. After you're finished with your Modbus operations, it's crucial to close the connection using client.closeIt. This releases resources and ensures a clean shutdown. 6. Error handling. Real-world Modbus communication frequently involves error conditions, e.g., network issues, device unavailability. Always wrap your Modbus operations in try-except blocks to gracefully handle potential exceptions and avoid your script crashing. Check the PyModbus documentation for details on specific exception types. 7. Example. Script snippet. A short code snippet to read two registers from address 1 could look like this. Try client.connect, result equals client.read, holding registers 1022, print result, dot registers, client.close, accept exception as E, print, F, an error occurred, /E. This demonstrates basic connection, reading, and error handling. Remember to replace the IP address with your device's IP. This brief overview helps you get started with Modbus RTU over TCP in Python, using the PyModbus library. Remember to consult the PyModbus documentation for more advanced features and detailed information.